Convection currents within the mantle provide one potential driving force for plate movement. Hot material becomes less dense and rises, and then when it rises, it cools down, becomes more dense, and sinks. And what we end up with are these rising and sinking currents called convection current in the mantle, the force that is driving the motion of the plates. There are three types of plate boundaries: the divergent plate boundary, convergent plate boundary, and transform plate boundary. First, we have convergent plate boundary. It happens when two plates are colliding. The plate being forced under is eventually melted and destroyed. We have continental and continental plate boundary. Both continental crusts are too light to subduct, so a continent-to-continent collision occurs, creating especially large mountain ranges. The most spectacular example of this is the Himalayas. Next, we have continental versus oceanic convergent boundary. This happens when continental crust on the left collides with oceanic crust on the right. Now, notice that the oceanic crust is sinking underneath the continental crust. Oceanic crust is more dense than continental crust. It's heavier, and so when the two collide, the heavier oceanic crust sinks underneath the lighter continental crust. When it sinks, it melts because it's hot down in the asthenosphere, and that melting rocks finds little cracks and crevices to rise through and ultimately erupts at the surface, forming active volcanoes. Continental versus oceanic crust forms a trench, an active volcano, and an island arc. Next, we have oceanic versus oceanic. Here, it's hard to tell which plate is going to subduct, as both have the same density, but eventually one plate, usually the older rock, will sink under the younger rock, and again we'll get this melting, which causes rising magma to create active volcanoes, which in this case form islands, volcanic island arc, also a trench. Another type of plate boundary is the divergent plate boundary, where plates move apart. Here, new crust is created by magma pushing up from the mantle. Best known of the divergent boundaries is the Mid-Atlantic Ridge. This submerged mountain range, which extends from the Arctic Ocean to beyond the southern tip of Africa. Along these boundaries, earthquakes are common, and magma rises from the Earth's mantle to the surface, solidifying to create new oceanic crust. The third type of plate boundary is the transform fault boundary. These are the boundaries where plates slide past one another. Take a look at this animation. You'll notice that the lithosphere floating on top of the asthenosphere is being driven by a convection current, which is causing them to slide laterally past each other. Right along that boundary in the middle, you get a lot of pressure built up, a lot of grinding over the plate, which is often released in the form of earthquakes. This is an example of a place where you can actually see a transform fault boundary. This is known as the San Andreas Fault, and it's responsible for the big earthquakes in cities in San Francisco and Los Angeles. And that is all for today. Thank you for watching.